Hi, everyone, and thank you for joining us today. My name is Brandon Searle, and I'm chair of the board of directors here at Building Transformations. Just coming online to give you a quick intro to the organization in case it's new to you, and then I'll introduce our speaker. Before saying that, I wanted to mention the platform we use. It's called StreamYard. It's going through some changes, so if you're having any issues or anything, just shoot us a note in the comments if you're having trouble with hearing or anything like that, and we'll do our best to make sure that's taken care of. I'll also mention everything's being recorded, so if you are having issues or miss some of the beginning or can't stay for the whole thing, just keep an eye on our YouTube page because everything will be uploaded there. So obviously, many of you know Building Transformations, and I just want to highlight a bit of what we do. So we foster industry innovation by providing programs which help our members push the industry forward. Our purpose is to advance our civilization by driving the building industry to be global leaders in innovation and technology. And to do that, we have several programs. Many of you are familiar with our events. Those are kind of like the main priority program, I would say, within the organization. And that's kind of how the organization got started. But building off of those events led to certifications and think tanks and awards and publications. And we continue to grow those programs and encourage you all to check them out and get involved. So just a bit more about our org. We have over 2,000 members, over 9,500 on our mailing list. Many of our members come from the industry, with roughly 40% from government, academia, and research institutions, which would be where I fall. And then just over 60% from as industry practitioners, which is always great. Just a little bit about our membership. So if you're interested in becoming a member and haven't joined yet, I encourage you to check it out. You can do that through our website. And then just quickly on our publication. So we just launched last week, I believe, in Montreal, the Innovation Spotlight Award for publication for 2025. That can be found on our website, where there's a lot of thought-provoking pieces written in there, as well as some projects highlighted and so on. And I wanted to thank our partners for delivering that publication launch last week at the Olympic Stadium. Finally, we have our events as mentioned. So obviously we have today's virtual event. Next week, we have our in-person event in Austin, Texas. If you haven't registered or haven't checked that out, I encourage you to do so. It's going to be a great event right at the University of Texas at Austin campus. There's going to be a ton of presentations, a great trade show, and some innovative things being discussed there. We then have two virtual events, one called Blueprints of the Future, as well as our Elevate Your Tech Staff and Your Tech Stack. That one's from Global E-Training, while the other one is from Bentley. Then finally, we have our annual event happening in Toronto in October of this year. That will be a 3-day event where you'll have project tours, speakers, our annual general meeting, as well as the award show. So I encourage you to mark your calendars. We'll be announcing the specific dates in October for that very soon. And finally, I just had to give a quick shout out to our mission partners. Without our mission partners, Building Transformations wouldn't be around. So thank you very much for everything you do and your continued support to innovation in the construction sector. Obviously, PCL, Bentley, Dassault Systèmes, Global E-Training, Hexagon, Imaginate Technologies, Leap Thought, Reality, and many more. I won't go through them all and bore you because you're all here to listen to the presentation. So with that, I'll get started. I'd like to introduce Federico Pensa. So Federico has a master's degree in building engineering and architecture from Politecnico di Milano in Italy. He immigrated to Canada in 2012. He built his career within several companies of the Fayolle group, starting as a project coordinator before advancing to key strategic roles, including quality manager, BIM-VDC manager, BIM-VDC director, and director of innovation and technology. His expertise and leadership led to his appointment as VP of technologies for Fayolle Group, which includes leading construction companies such as Magil Construction, SVT, Enercor, and Les Excavations Payette, Apologies for my mispronunciation there. In his current role, Federico is responsible for defining and implementing technology strategies, overseeing BIM-VDC initiatives, and integrating innovative solutions to enhance the efficiency and competitiveness of the group. His work focuses on pushing the boundaries of digital construction, fostering collaboration, and leveraging emerging technologies to optimize construction management and execution. So with that, I'll welcome Federico to the stage for his presentation. Following the presentation, we'll have a live Q&A with Federico. Thank you, everyone.
Good day, everyone. Thank you for being here today. It's a great honor to present the CRJDA Sainte-Thérèse project, an initiative that has not only pushed our boundaries of construction management innovation, but it also earned the 2024 Spotlight Innovation Award in Construction Management. Throughout this presentation, I'll show you how we leveraged technology to streamline construction, improve safety, and optimize logistics. Before starting, I'd like to introduce myself and my company. My name is Federico. I am currently the Vice President of Technology for Fayolle, a construction group which owns several construction companies. One of these companies is Magil Construction, our general contracting and construction management company. Magil was founded in Montreal in the 50s by Louis Magil, an immigrant from East Europe. And over the years, we participated in the construction of a good part of downtown Montreal, as we can see in this map. Since Fayolle's acquisition, we've been expanding and we now have offices in Ontario and BC. For this project, Magil partnered with Tisseur, forming a joint venture that allowed us to combine our expertise and tackle the unique challenges of the CRJDA Sainte-Thérèse. Tisseur is a Quebec-based contractor and shares many similarities with us, our values, our approach to construction, and even many of the same digital tools. However, their strong infrastructure expertise made them the perfect partner for this project, complementing Magil's strength in complex building construction. This partnership is not a one-time collaboration. We already have several joint ventures on the way and anticipate even more in the future. In today's construction industry, where projects are increasingly complex and large, joint ventures are becoming a necessity, allowing companies to pool resources, share expertise, and expand their capabilities to take on more ambitious projects. Let me say, however, that our joint venture is more than just the sum of two companies. It is a true collaboration, an example of how two firms can integrate their knowledge, tools, and best practices to deliver something truly exceptional. And the CRJDA project is a statement to this, a project that neither of us could have executed as effectively alone, but was made possible through this partnership. So back to Magil, our core business has traditionally been high-rise projects in Montreal, realized through construction management contracts. However, over the past 10 years, we worked hard to diversify our operations in order to reduce risks and increase revenues. We now have a very diversified portfolio that includes institutional, industrial, commercial, sports facilities, public transportation infrastructure, and so on. We work with both private and public clients and with pretty much all kinds of contracts, lump sum, construction management, EPCM, design build, etc. We normally seek projects with high added value and complex deliverables like LEED, BIM, and so on. So Magil does not own facilities. We don't own equipment, heavy machineries, materials. Our assets are instead knowledge and expertise, which are held by our people, either our employees or the companies we work with to execute our projects. This is important in order to understand our vision for technology in construction. A construction project is not the product of a single company. It is the success of a team made up of dozens of companies, clients, consultants, subcontractors, suppliers, specialists. As a construction manager, our role is to act as the conductor of an orchestra, ensuring that all these different players are aligned and moving toward the same goal. That's why, for us, technology is about helping people to communicate, collaborate, coordinate. It's about giving teams better tools to understand the project, anticipate challenges, and make informed decisions. Consider that construction is fundamentally different from manufacturing. In a factory, the prototype and the final product are identical. You test, adjust, and then mass produce. In construction, there is no prototype. The first time we build something is also the last. Every project is unique. Every site is different, and every schedule has its own constraints. This introduces inherent risks that cannot be eliminated, but they can be managed. And that's exactly where technology plays a crucial role. We use technology to simulate, test, and plan as much as possible before building. We use it to reduce risk and improve predictability. We use it to bring clarity to complexity. Over the past 5 years, our commitment to advancing construction management has been recognized at the national level. We have earned 5 nominations and 3 wins at the Spotlight Innovation Award presented by Building Transformations in the category of construction management. And this year, our work on the CRJDA Sainte-Thérèse project earned us this recognition once again. So let's now dive deeper into what made the CRJDA project stand out and how we implemented these innovative methods on site. The Centre de réadaptation pour jeunes en difficulté d'adaptation, CRJDA, de Sainte-Thérèse, is a 12,000 square meters rehabilitation center designed to provide a safe and structured environment for youth aged 6 to 17 facing adaptation challenges. The facility includes 9 residential units, classrooms, multi-purpose spaces, a gymnasium, an art studio, and outdoor recreational areas such as sports fields, gardens, and themed play modules. This project is more than just a building. It is a place of transition and rehabilitation designed to support youth in their development. The architecture was conceived by ACDF, whose artistic vision focused on soft, welcoming forms that avoid an institutional feel. The building features curved structures, warm materials, and a strong connection with nature, creating an environment that promotes well-being and reintegration. The client, Société Québécoise des Infrastructures, SQI, in partnership with the Centre Intégré de Santé et des Services Sociaux de Laurentides, opted for a design-build contract for this project. This approach was chosen to ensure faster delivery, cost control, and better integration between design and execution, allowing flexibility in adapting the evolving needs of the facility while maintaining a strict schedule and budget. One of the most significant challenges was the fast-track nature of the project. Construction began while parts of the design were still being finalized, meaning that excavation and foundation work were already underway while upper floors and other sectors were still being developed. This required constant coordination and flexibility to adapt as the project evolved. Another challenge was the fact that, unlike a typical building with the repetitive floor layouts, the CRJDA features curved forms and highly customized spaces. There are no standardized floors, and almost every section of the building required a different approach. This architectural complexity made traditional coordination methods ineffective, requiring an advanced BIM-VDC strategy to maintain alignment between the trades. Beyond the complexity of the structure itself, the project required the integration of MEP systems, security infrastructure, and architectural components, all while ensuring that the facility remained functional and welcoming for its users. This level of coordination was intensified by the need to hide security features to maintain the therapeutic environment. Moreover, the fast-track approach meant that different phases of construction overlapped. At one point, we had rock excavation on one side of the site, concrete and mechanical works in the middle, finishing work already underway on another side. This created significant logistical challenges, requiring precise planning and real-time site monitoring to ensure safety and efficiency. And finally, This project was the first design-build joint venture between Magil and Tissot, meaning that we had to align workflows, standardize communication, and integrate new processes while executing a high-stakes project. BIM and VDC were essential in managing this collaboration, ensuring all teams worked within the same digital environment to maintain efficiency. The success of this project was not just about using technology, but about how we used to solve real challenges. Each of these tools played a critical role in improving efficiency, coordination, and risk management, starting, of course, by the use of BIM-VDC. Then we brought all key players into a single federated BIM environment where designers, contractors, and trades could work together in real time. This meant that potential conflicts were identified early, minimizing costly reworks. Drones gave us high-frequency real-time site data. This wasn't just about getting aerial images. It was about validating excavation levels, monitoring work progress, and improving site safety. Instead of relying on sporadic manual checks, we had accurate, measurable, georeference data that helped us track every phase of the construction with precision. Laser scanning and 360 cameras helped us verify as-built conditions against the model throughout construction. This allowed for quick adjustment when discrepancies arose, particularly for concrete slabs, structural alignment, and envelope coordination. These tools reduce the need for guesswork and provide a clear documented record of progress and quality assurance. And of course, one of the biggest challenges was managing multiple activities happening at once: excavation, structural work, mechanical installation, and finishing. So 4D simulations allowed us to visualize, plan, optimize every major sequence before it happened. We use these tools to improve the efficiency of crane positioning, concrete pours, steel installations, mechanical works, major equipment deliveries. This level of foresight helped prevent costly delays and made site logistics more predictable and safer. So let's move into the real-world application of this technology on site. I'll showcase now how we used BIM drone for the simulations, laser scanning, and automation. We'll start at the beginning, how we use drone and georeferencing to improve site mobilization and excavation. So from day one, we deployed micro drones to track progress and verify excavation accuracy. To standardize data collection, we used a popular software to plan flight paths and automate missions. This ensured consistent, high-quality data collection with minimal human input. Micro drones were more efficient, lower cost, and required fewer regulatory approvals than traditional drones, making them an ideal tool for continuous site monitoring. Now, having drones capturing site data is one thing. Ensuring precision and consistency in every data set is another. That's where ground control point, or GCPs, came in. We fabricated concrete mounted markers installed at fixed location across the site. Each marker was surveyed once at the beginning and never moved. Now every drone flight was automatically georeferenced, ensuring that all datasets aligned perfectly with the BIM model. This meant that we could automatically compare new drone data to previous site conditions, integrate excavation levels and structural elements with BIM models quickly, and ensure high precision without additional surveying for every flight. Once we established a consistent georeference dataset, we integrated drone surveys directly into our BIM workflows. Every drone flight was automatically overlaid onto the federated BIM model. Excavation levels, foundation, and structures were identified against design models in real time. Potential issues, misalignment, or delays were flagged quickly. Once drone flights were integrated into our workflow, we processed the data in a dedicated software to generate photogrammetric point clouds. This allowed us to calculate excavation volumes with precision, preventing disputes over quantities. Monitor excavation profiles and ensure alignment with design specification, one another thing. We can see here on the right, two aerial views showcasing the progress of concrete foundation works. This highlights the scale and complexity of the foundation phase. The next step was ensuring that excavation met the exact design specifications. On the right here, you see a snapshot of surveyed excavation levels. And on the left, a 3D mesh model was generated, showing the actual rock layer elevations, which ended up being, as always, different than what expected. This was critical for verifying contractor quantity claims and ensuring fair compensation. Here we take the process one step further. This image shows the federation of excavation data with the structural BIM model. This ensured that structural elements were aligned with the excavation footprint before concrete work began. In this slide, we see a fully integrated dataset where drone-generated point clouds were automatically aligned with the federated BIM model. And in the right section shows several examples of actual applications, such as excavation slope verification to ensure safety compliance and excavation depth interference checks. A unique challenge in fast-track project is the need for temporary structures before the final design is complete. This slide shows an example of this challenge. The tower cranes foundations were integrated into the BIM model. The drone surveys ensured that placement did not interfere with the final structural elements. Using this method, we ensured that temporary structures supported ongoing work without impacting long-term construction. One of the most complex integrations in this project was the coordination of 142 geothermal wells. The geothermal system maintains inlet water temperatures between 10 and 15 Celsius degrees, delivering long-term energy savings. This slide shows how drone imagery and 3D modeling ensured proper design and placement. Each well, 6 inches wide, 200 meters deep, was accurately positioned to maintain optimal efficiency. Another great example which show how powerful and cost-effective is the use of BIM and drone imagery is the under-slab coordination, which are often poorly designed and coordinated. Design updates were directly integrated into the collaborative platform, allowing for rapid execution adjustments. With these tools, we ensured that all underground utilities and slab mechanical systems were accurately placed before pouring concrete. Beyond visualization and coordination, drone surveys played a major role in verifying completed work for invoicing and payment approvals. In this example, the highlighted red areas indicate tracked foundation progress, with each update providing a clear time-stamped record. This eliminated disputes regarding quantities completed versus quantities invoiced, and ensured the subcontractors were paid based on an accurate progress tracking. By having aerial validation of foundation and structural phases, the project team improved client-contractor relationships, avoiding unnecessary delays in approvals. In addition to coordination and progress tracking, drone data was heavily used for safety compliance. The safety team used drone surveys to verify excavation slopes, ensuring compliance with the regulatory requirements. And moreover, the safety team leveraged high-resolution orthomaps captured by drones to better collaborate with the site logistics team, and ultimately to better communicate site setup, access path, and potential hazards to stakeholders. But managing logistics and equipment movement on fast-track projects requires more than just good coordination. It requires precise simulation and planning. We used a separate, dedicated collaborative 3D platform to simulate logistics milestones such as concrete pump reach, circulation paths, and safety zones. By testing different setups, we minimize disruption to surrounding areas while maintaining safe operations. This allowed crews to anticipate site access constraints and optimize pump placement before operations began. Or Again, mobile crane coordination for the steel canopy installations, ensuring safe lifting zones. The ability to visually communicate crane operations to all stakeholders significantly improved coordination. Here you see an aerial view showing simultaneous structural envelope and interior works. As I mentioned before, these fast-track projects required multiple activities to run in parallel. Concrete structure was still progressing while envelope installation began. Interior work started in completed section while other areas were still under construction. Again, drones provided real-time oversight, allowing us to monitor all phases in a single dataset. Using drone imagery, we conducted systematic quality checkpoints. For example, before any major concrete pour, it was essential to validate that rebar placement, mechanical systems, and formworks were installed correctly. Or, another example, on the image on top, we detected additional rock to be excavated before proceeding with the foundation works. To further enhance quality control, we overlaid drone-generated orthomaps with the 2D structural and rebar plans. This provided a clear visual method to track construction accuracy. Several slabs contained an embedded glycol heating system, a critical feature for long-term energy efficiency. We can see an example in this picture which shows the high-resolution imagery for documentation and future reference to ensure precise placement and preventing costly slab corrections post-pour. Once concrete was poured, laser scanning was used to verify levelness and flatness before finishing work began. We used our own LiDAR device to scan the entire slabs with high precision, identifying any deviations from design tolerances and letting the contractor to fix the situation well before the finishing works had to start. Another example was represented by the highly customized non-regular curtain wall system this building featured. Ensuring precise alignment was critical for aesthetic consistency and architectural intent, but also structural performance and weatherproofing. On the top, laser scan verification was used to check structural compliance with envelope tolerances. Below the image, you see a photograph of the actual connection between building sections. This process eliminated misalignment risk, allowing the envelope to be installed efficiently and accurately. 4D simulations. 4D simulations were a key tool in our project execution, not as a marketing stunt, but as a practical planning and decision-making tool. The goal was to review and optimize the project schedule by integrating feedback from specialty contractors, consultants, and the construction team. These simulations allowed teams to visualize critical path activities, helping them detect risks early and identify optimization opportunities. We initially focused on excavation, structure, and envelope at a high level, ensuring the schedule was realistic and coordinated across disciplines. But this was just the start. In fact, while high-level 4D simulations focus on overall project sequencing, we also developed detailed simulation for complex areas like the main mechanical room. These highly detailed 4D models broke down installation sequences step by step, ensuring that every trade knew their role. The simulations helped assess the impact of design and coordination decisions on the schedule. Color coding was standardized to match our coordination templates, providing visual consistency and better communication. Beyond schedule planning and coordination, 4D simulations were also used to model the movement of large mechanical equipment throughout the site. These simulations optimized path selection, ensuring equipment could be transported with minimal disruption to ongoing construction. Potential obstructions were identified in advance, allowing teams to coordinate around scheduled deliveries and avoid conflicts. This visual representation of logistics planning significantly improved communication with contractors, helping them better prepare for future site activities. And for this simulation were also an effective tool for communicating safety measures and risk margins to the client. The ability to demonstrate logistical plans in a clear visual format helped build confidence and align expectations. This way, we avoided unnecessary costs associated with excessive safety measures. I already said how this project was special to us because it was only our second design build project and the first of this scale. Design build offered a unique opportunity to not just execute a design, but to optimize it and push value engineering to the limit. Unlike a traditional approach where contractors receive a finalized design, here the design team, consultants, and key subcontractors were fully embedded in our workflow. This meant that we could apply all the experience and expertise we had built in our department, ensuring that proactive use of BIM-VDC and digital coordination directly influenced decisions from the earliest phases. First, we implemented a standardized color system for all disciplines. The same system is applied across all our projects, which results in faster coordination meetings and clearer understanding for all teams. Our coordination workflow leveraged 162 parametric-based search sets and 7 different appearances templates. These tools allowed us to instantly filter and analyze the model based on specific coordination needs. Quantity takeoffs, constructability reviews, and work tracking have been made easier this way. A total of 44 standardized clash tests were set up and run frequently, ensuring that design modifications and coordination changes were immediately validated across all systems. When an issue required direct client input or contractual clarification, it was escalated into our project management RFI module. This ensured that critical issues were not just discussed internally, but were properly documented and tracked. However, let me tell you that while these tools are powerful, they are only one part of a comprehensive coordination workflow. While clash detection remains a crucial instrument, our coordination workflow starts with human-driven virtual coordination reviews. Before running clash tests, we conducted virtual walkthroughs of each sector, identifying issues that automated clash detection might miss. Not all clashes are equal. A large geometric conflict might be insignificant, while a minor routing issue in a critical path zone could have major schedule implications. Experienced coordinators assessed issues in the context of schedule, deliveries, milestones, building code, and asset management requirements. This process ensured that coordination was driven by practical expertise, not just software outputs, making our issue resolution process more effective and strategic. This college showcased real-world examples of design optimizations achieved through proactive BIM coordination. We can see here spatial conflicts resolved before execution, MAP layouts optimized to improve accessibility, serviceability, and constructability, value engineering, which led to cost reduction by identifying more efficient construction methods. This level of integration was only possible because of the design-build framework, which allowed us to become active contributors in shaping the project. This project required us not only to execute with precision, but also document, verify, and track every aspect of construction. The end goal was to deliver an as-built federated BIM model, which was the foundation for the 7D asset information model, a contractual requirement from the client. The site team used mobile device to update the BIM model with real-time work completion data. For example, here we see concrete block wall progress being tracked for invoicing, ensuring accurate expense validation before approving payments. This approach improved cash flow, reduced disputes with the trades, and expedite approvals, keeping the project financially aligned with progress in the field. Site teams directly linked photos to issues in our collaboration platform, reducing the need for physical site presence. This improved communication between field and office teams, allowing for quicker response times to issues. QR codes were placed strategically around the site, linking to corresponding locations in Procore and issues in Revizio. Issues have an associated 3D view, which we set to correspond with the physical QR code location on site. So whenever someone scanned the QR code, the correspondent 3D view opened up on the iPad. This allowed on-site personnel to instantly pull up relevant BIM views for inspections and verifications instead of flipping through drawings. 360 degrees cameras were often and recurrently used to create virtual site walkthroughs, for a total of 534 walkthroughs. These virtual visits allowed teams to compare executed work against the planned BIM models, ensuring alignment with design. Parallel navigation between physical reality and digital model gave project teams a clear understanding of progress. 360 virtual walkthroughs were used to spot check differences between the as-built and as-planned BIM models. Any misalignments or error were flagged to our collaboration platform for resolution. Far from being able to check every detail, this proactive approach pushed all contractors involved in modeling to quality check their final models to be as close as possible to the works executed in reality. The goal was to create an high-quality as-built BIM model, which is the necessary requirement with the 7D asset information model, which was the final constructural deliverable. Data from design teams, specialty contractors, and site execution was structured and fed into a centralized workflow. This ensured that the final BIM model was not only geometrically accurate, but also rich in asset data for long-term operations and maintenance. Asset management information was first collected in Excel form from contractors and suppliers. Dynamo scripts were developed to automate the extraction, validation, and integration of this data into the BIM model. This process reduced manual data entry errors and improved efficiency in building the as-built model. A dedicated Revit plugin was used to sync structured asset data from Excel back into the as-built federated model. This final step ensured that the BIM model reflected all as-built conditions, including equipment, metadata, installation details, and maintenance information. The result was a fully developed 7D asset information model ready for handover to the client's facility management team. I want to discuss more that while the transition from construction to asset management data is a critical step, it is technically speaking pretty straightforward, and the real challenges lie elsewhere. First, as we saw, ensuring a high quality as-built model. This is difficult because it requires continuous updates from all parties involved in modeling. If companies wait until the last minute to update their models, these updates are often incomplete. Maintaining discipline in updating the model throughout the project lifecycle is key to avoiding a last-minute scramble. Second, defining clear information requirements from the client. For an asset information model to be useful, the client must clearly define what their assets management team needs. Ideally, the asset managers should be involved from the start, so that the Revit parameters are structured around their requirements, rather than just design and construction needs. Once these requirements are set and the parameters defined, they need to be clearly communicated to all contractors, so they understand what data they must capture and deliver and under what form, avoiding surprises at the end. If this discipline is maintained throughout the project, rather than treating asset modeling as an afterthought, the final step of compiling the asset information model becomes as easy as pushing a button. So I covered a lot of ground in this presentation, but beyond the technical details, this project gave us important lessons about what it really takes to innovate in construction. Innovation in construction is not about technology alone. It's about how we apply it in a way that fits the realities of our industry. It's about discipline in execution, clear processes, and risk management rather than chasing trends or flashy tools. And most importantly, it's about aligning all stakeholders, client, consultants, contractors, suppliers, toward common goals. This project was an example of how technology and process discipline can work together to drive real results. I really believe that innovation in construction is not held back by a traditional mindset, but it's more about risk aversion and project complexity. Like I said earlier, construction is a one-off process. Every project is different. There is no mass production, and small errors can have huge cascading consequences because of the nature of this industry. Dozens of different companies with a highly regional reach collaborating mostly on processes in series and operating on very low margin and extremely high competitive markets. This means that any innovation must reduce risk, not increase it, and that new methods need to be proven and repeatable to be widely adopted. Execution is more important than technology. The hardest part of BIM and digital workflows isn't the tool. It's the discipline to maintain high quality data throughout the project. If modeling, coordination, and updates are left to the last minute, the benefits of these technologies collapse under bad data. Collaboration is more important than ever. The future of complex construction projects isn't about individual companies competing. It's about how we collaborate. Design Build enable us to integrate consultants, subcontractors, and specialists into our process early, unlocking optimization opportunities that wouldn't have been possible in a traditional contract. The tools I showcase in this presentation are not just for us. They are for breaking silos and improving communication across all teams. Finally, innovation must be practical, not just theoretical. A flashy 3D simulation doesn't matter if it's not understandable to the people using it. A sophisticated coordination model is useless if subcontractors don't trust it and still rely on paper drawings. Our approach was simple. Every innovation had to be clear and useful. These lessons are hopefully not just about this project. They are takeaways that apply for every complex construction job moving forward. This was a major step forward for us. So thank you for your time and interest in this project.
Thank you, Federico, for that presentation. Can you hear me okay?
Yes, I can. Can you hear me?
Yes, perfect. Sounds good. So I'm going to remind folks, for everyone who's joined us, if you have any questions for Federico, please put them in the comments there, and I'll keep an eye on those. In the meantime, I have a few questions kind of created ahead of time. So maybe I'll start with those while people can think through their questions. So Federico, again, thank you for that. Question is, so I'm in Atlantic, Canada, and on the East Coast, I would say the kind of BIM-VDC maturity is continuing to grow, but might not be as mature compared to some of the larger urban centers across the country. So, and furthermore, once you go beyond the general contractors or the construction managers, and work with the sub trades and so on, they might not be as tech savvy. So, I'm wondering, like, how do you balance innovation with subcontractor adoption, kind of bringing them along, and especially with some of the trades where it's maybe not even that they don't have the skills to do it, but they just aren't aware of how to do it and they've never been trained or seen it before. So how do you balance that through these projects?
Well, the approach is different depending by the type of project and particularly the type of contract. There are some contracts that gave us leverage, contractual leverage in pushing more for this innovation. But that's not true for most of the projects. So generally speaking, you gotta have an open mind toward the subcontractors, because like I said in the presentation, in the end, the success of a project is very much determined by the success of the work team. So you need them on board, and we prefer an approach by carrots, not with the sticks. So we try to show what's in it for them, understanding that every different players and every different stakeholders might have different needs and different potential gains from the project. So they kind of all needs their tailored approach. Some of those are recurrent collaborators, recurrent trades we work with. So it's also not about the singular project. It's more about on the long period. We saw many that years ago they weren't using any innovation and in BIM approach, and nowadays it became pretty regular for them. So we like to think that we played a role in that advancement. The second thing I want to mention is that we're like the big player in the project, like as the general contractor, right? So we're supposed to have the more resources. So of course we're a for-profit organization, so it's not about giving away gift, but at the same time we try not to like go look for small charges. Like we try not to charge for licenses or for the collaboration platform. We gave access to our drone data or open space platform. Again, depending by the contract, of course, there are contracts that are more in a control state, but we gave them a chance to like a free pass. And most of the time, the second project or later on, they came in with their own licenses.
Yeah. No, that's great. And yeah, I do wonder too, like, because like sometimes the barriers to accessing that is the cost of the technology. So as the general contractor, you almost take on the cost and are able to share throughout your supply chain with the subtrades, the same licensing. That's just the nature of the contract. Yeah. No, that makes sense. We have a bunch of questions coming in now, so I'm going to go away from the ones that we have in our Q&A bank and go to these ones. So one is, and this one might be tough to maybe define BIM process, but I'll let you answer it how you see fit. But in terms of cost, could you specify numerically the reduction in project cost achieved by fully implementing the BIM process in this project? I think just from the way I interpret that, I've seen some projects where they showed like a reduction in change orders or a reduction in cost overruns or whatever. Were you able to actually quantify through the BIM the benefit cost wise?
Yeah, that's a classic question. We're discussing ROI here. So yeah, my stand on ROI is that no, it's not something that can do any calculation. The reason, well, I'm not saying anyone can, but the size of our company doesn't really let us. We don't have that many similar projects. If we were doing like 25 hospital or per year, or in this case 25 similar projects, then we would have been maybe able to compare statistic and came out with some trends. But even in that situation, every project, as much as similar, it's basically a different project altogether. So adopting BIM-VDC approach, you can came out with some metrics like, okay, I detected 12,000 issues, but that doesn't tell you how many issues you would have caught without the BIM, because it's not like BIM, you're doing zero coordination. So it's like you don't know how the project would have performed without BIM. That being said, we don't stress too much on ROI because we see this like, PDF came around or Outlook. Nobody today asks what's the ROI of using email over regular mail or using Excel spreadsheet instead of doing this by paper, right? It's clear that it's better. It's the ROI coming up with actual ROI is complicated, but with that many companies involved, any tools that can improve coordination, collaboration, we strongly believe the ROI is there.
Yeah, no, and coming at it, like being at a research institution, we get asked this whether it's around like any type of new digital technology or process or whatever. And I've seen like frameworks done of how you can measure those performance metrics. There's Halifax International Airport did a pretty neat study with some implementing BIM and how the trade-off versus historical projects. But you're right, it's not an apples to apples approach by any means.
And you need the data.
Yeah,
someone else can have all the metrics.
Yeah, you need that owner to be willing to, right off the beginning of the project to take that data and share that data and so on, and then get it from your suppliers and the whole project team. So I'm going to keep going. We only have like 3 to 5 more minutes, so I don't know if we'll get to all the questions, but next one is first, great presentation. How many people in the VDC team were involved in managing clashes with Revisto for this project?
Oh, well, specifically managing clashes, we had like a BIM coordinator and a BIM manager on our team. Then we have an expert for drone, laser scan for the simulations. If I also count people from the trades, I believe we're around like 10, 15 people involved in the coordination process, those that actively. Then, every trades, you have the designer coordinator, but sometimes there is a whole team behind them, particularly for the most complex systems.
Perfect. Yeah, thank you. Sorry, I'm on a few different screens. I have a different setup, so I need to make sure I'm not missing too many questions here. So next one is regarding the use of 360 images and the comparison of the view against the as-planned BIM. Could you explain if there is any specific method in use to automatically match these two views, or the view in BIM is manually retrieved corresponding to the 360 image?
Oh, well, yes, this is an easy one. It's the application that does it automatically. I didn't really mention many software in the presentation. I didn't want this to be about which software we're using. However, I'm sure that most of people are able to recognize those tools. We use OpenSpace, and the alignment is done automatically. I think they use a mix of AI, but there is a human intervention. But you only need to align the view once, because they use the 2D sheets, and once the 2D sheets are aligned with the 3D model, then every virtual walkthrough came in aligned, more or less. It's not a survey level alignment, of course.
Yeah, perfect. And just going here, the next one is around cost savings as well. I don't know if you're able to quantify how much was the savings using all the technology that you use throughout the project. I assume that's a bit of a tough
that's the
calc.
same. Yeah, it's the same as before. I can say that the project ended up being making good profit. We finished in budget and pretty much on schedule, which is not common in the construction industry nowadays. So
Yeah, that is, especially right now.
I don't want to take all the merit. It wasn't only about BIM-VDC. It was a great team, great players.
It takes a full crew, and having strong suppliers and planning well in advance and everything like that, which is actually the next question here. This will probably be our last one, just given the time. This one's from Dylan. The client had clear deliverables on this project and made for clear information and data communication. Well done with implementing. How often was the technology or software go through planned or unplanned updates?
The technology software go through unplanned updates, like updating the software, the updates of the software, or the updates of the 3D model?
That's a good question. I'm going to assume updates of the 3D model, and then maybe because the updates of the software is a bit out of your control, and then you can use previous licenses.
It's usually it's at least weekly on the coordination platform, but we were also running the BIM 360 on the back, which only the actual author, the designer, were access to, and we didn't restrain how many updates they were doing on the back. But once a week, the team had to be ready to share the federated model for the review of the coordination team.
Okay, thank you. And Dylan just said software updates for a long project. Yeah,
I think he's thinking particularly to Revit. That would be a question for the BIM manager on the project. I don't think we maybe did one Revit update at the beginning. This wasn't like a very, very long project. Still 2 hours and 2 years and now. But yeah, we have project in portfolio that have been running for like 6-7 years, and those projects that are on a lump sum public contract particularly, so we don't have control over design, so we cannot really impose, or we can kindly ask if the designer would like to update to a more recent version of Revit, but it's not always happening. So yeah, we still have project running in Revit 2021 or even 2020, I think. And yeah, it's an issue.
For sure. Okay, so with that, I think we're at time. I guess I want to thank you, Federico, for your continued support to Building Transformations and for your great presentation and highlighting some of the lessons learned in the project. There are a few other questions coming in. I'd encourage you to maybe reach out to Federico, maybe on LinkedIn or something, if that's okay with you. If you have any other questions for him. Thank you again. And thank you all for joining today. I hope to see some of you in Austin next week. And
thank you for having me.
Thank you. Take care.